So if I drew this up here, what's this O going to represent?
Oxygen.
Oxygen, right? So it's the name of the chemical, right? Or the element. This number is the
I have no idea.
atomic mass. And this is the atomic number. Okay? So a few things when we start off. Let's clarify a few things. We have matter, mass, and weight. If I asked you to define matter, how would you define it?
It's just stuff that takes up space.
Stuff, right? It's stuff that takes up space. And what's mass?
How big it is, how much space it takes up.
Getting close. It's how much matter is in something. And then weight is just the gravitational pull, right?
Right.
Okay, so here's an example. You're in outer space, right? You're on the moon. How cool is that? You're one of the few.
So cool.
Okay, when you're on the moon, does your matter change at all?
No.
You still take up the same amount of space, right? Does your mass change?
No?
No, same amount of matter is inside of you, right?
Yeah.
Does your weight change?
Yes.
Why?
Because the gravity is different.
Gravity's not pulling on it the same way, right?
Right.
Okay. So when we're talking atomic mass, we're talking about the amount of matter. That make sense?
Mm-hmm.
Okay. So we'll get back into this again. So when we talk about the atomic number, what are we talking about? Do you know?
The atomic number.
Yeah, right up here.
It's like the number of elements it is, but I don't know.
It's the number of protons and neutrons.
The nucleus?
Sorry, number of protons. And then this is the number of protons and neutrons.
Like added together?
Yeah, added together.
Okay.
So from here we know that oxygen has 8 protons. And then we know that added together protons and neutrons are 16. So if we were to look at this, would you be able to tell, well, let me think of my question actually. Actually, I don't want to answer the question. So if we took any other chemical or element, sorry, I keep saying chemical, how would we find out the number of neutrons that it has?
Half the atomic mass.
Yeah, so we just take
It's the same as the number of
the
protons.
mass subtracted by the number, and you get the number of neutrons. That make sense?
Mm-hmm.
Just because this says protons, this says protons, the only difference is
Is it not
this
always
says
the
neutrons.
same?
No, not always. It'll vary sometimes. But so that's kind of the rule. Subtract numbers from mass, and you'll get the number of neutrons. Cool? So there's probably gonna be a question like that on your test. They usually do that. All right.